The slump test is an essential procedure used to assess the workability and consistency of fresh cement or concrete. It provides valuable insights into the fluidity and plasticity of the mixture, which are crucial factors in determining its suitability for construction applications.
Here are the apparatus and materials. First is the Portland cement, the fine aggregates, the coarse aggregates, the slump cone, shovel, base plate, trowel, tamping rod, ruler, and lastly, water.
To start with our experiment, first we will weigh the required quantity of cement according to the predetermined ratio of 1:2:4 for Class A mixture. Repeat the weighing process for the sand and gravel, ensuring you weigh the correct proportions for each material. Start by pouring the cement and gradually add the sand, ensuring even distribution. Use a shovel or mixing tool to blend the cement and sand together until they are well mixed. Add the coarse aggregate into the mixture and again blend the materials thoroughly to achieve a uniform distribution. Gradually add water into the well, starting with a portion of the required amount. Mix the cement mixture thoroughly for several minutes until the materials are well combined and a homogeneous mixture is obtained. Once the cement mixture reaches the desired consistency, transfer it for a slump test using a suitable container.
Before starting the test, it is essential to ensure that the slump cone is clean. Moisten the cone with water to prevent the concrete from sticking to the cone, allowing for easier and more accurate measurements. Put your slump cone on the plate and stand in the foot pieces for stability. Fill the first layer to 2 and 5/8 inches with the concrete mixture, making sure it is even inside the cone. Rod the layer 25 times, making sure to cover all the surface area inside the cone, slightly angling the rod to get to the edges. Do not tap the side of the cone. Proceed to fill the second layer to 6 and 1/8 inches or simply the 2/3 of the cone by volume, making sure the concrete layer is even. Carefully pour the concrete into the cone while maintaining a uniform flow and avoiding any segregation or trapping of air bubbles. Apply 25 blows to the second layer using a consistent and uniform tamping motion. Make sure to penetrate the first layer by 1 inch. After compacting the second layer, proceed to fill and compact the third and final layer of concrete in the same manner. Fill the cone to its brim, slightly overflowing the top. Rod the layer 25 times, making sure to cover all the surface area inside the cone, slightly angling the rod to get to the edges. Do not tap the side of the cone. After filling and compacting the concrete in the cone, level the surface of the concrete using the tamping rod. Remove any excess concrete from the top of the cone. Hold the handles of the slump cone firmly and lift it vertically in a smooth upward motion. Avoid any lateral or twisting movements while lifting. The lifting process should take between 3 and 7 seconds. Flip the cone upside down next to the slump concrete and place your tamping rod on top of the cone and over the slump concrete. Using the ruler, measure from the display center to the rod and record the slump to the nearest quarter of an inch. The entire slump procedure needs to take place in 2.5 minutes. A slump value of 1 inch or 25 mm was obtained in the experiment. Specifications and standards for the slump test can vary depending on the project requirements, regional guidelines, and construction standards. Different applications may have different acceptable slump ranges based on the desired workability and performance of the concrete. The table shown emphasizes the different specifications for slump tests.
Based on the standard specifications shown in the table, our slump value falls within the range of 0 to 25 mm, which is typically associated with the dry mix used in road making. Additionally, a compacting factor of 0.78 is mentioned, which may further indicate the dryness of the mix. A dry mix typically has a lower water-to-cement ratio, resulting in a stiffer concrete mixture. This type of mix is often used for road construction to achieve better compaction and durability. Several factors can affect the slump test results. It's important to consider these factors and take appropriate measures to ensure accurate and meaningful results. Here are some key factors that can influence the slump test and recommendation for handling them. Follow the recommended water-to-cement ratio closely, as specified by the concrete mix design or project specification. Any deviation from the prescribed ratio can affect the slump and other concrete properties. And lastly, follow proper mixing procedures, ensure sufficient mixing time, and use appropriate mixing equipment to achieve uniform and well-dispersed concrete. By considering and addressing these factors, you can obtain more accurate and consistent results from slump tests, enabling better assessment of the concrete's workability and consistency.